that all I have to do? Let's see if this thing works. I'm waiting for the stream to come back to me to see if it looks good. It looks good. All right. This is the final day of Avenue Code 2021. Day 25 is unlocking in just under 25 minutes. I'm starting a bit early so that I can get set up. I don't think it's going to be a long stream because usually the last day is not so hard. But you never know. You never know. We'll make a placeholder for it. Actually, I don't want to copy day 21 to do that. Hold on. I want to have the correct keyboard layer on. Delete that. What's a good day that has actual input? 19? No, that's too big. Okay, next year, I need to have a template. Day 25. New text file, 25.txt. All right, and day 25. Yeah, a template, if I don't have a full framework that does this for me. If I have that, maybe it don't need a template. Audio working, video's working, not dropping any frames. I have 28 viewers in chat, but I don't know if any of them are human. Welcome bots and humans, lurkers and all. We're going to start Avenue Code. It's going to unlock in 23 minutes. I'm kind of setting things up before then. Well, hey, there, CodeMuck. Now we have an actual human chatter. I presume you're human. I maybe should not presume so much. I don't know, it was weird. I noticed starting up the stream, like before I even started the stream, my bot was saying that there were 26 people in chat. I'm like, there can't be 26 people watching my channel just in the off chance I might start. So I'm like, how many of these accounts are bots? And I started looking at the names. I'm like, yeah, I don't. There's a few names I recognize, but those are other coders who probably have bots running, and yeah. So it was just weird to see so many. Usually I see like only 6 or 7, but there are 25 tonight. Hey there, Musin. So Musin, not just you. There were 24 others, I think, for one reason or another, who just decided to be in my channel before I even hit the start stream button. It makes me a little bit nervous. It's like if you I don't know, see a whole bunch more people going down one street than normally do, and you're like, is there something going on down there that I don't know about? That kind of a feeling. It's like probably just a coincidence, probably just bots, who knows. Some of those are analytic bots, yeah. But why would they be watching me? I have no idea. And why now and not like yesterday or the day before? Really weird. Okay. I got an explanation from Mrs. Rightmove, but I won't repeat it. She has an opinion about that. Okay, so ready to go? I like to have a bunch of time to set up and also maybe warm up with another day, especially if today's probably not going to be that big a challenge. And you never know. Oh there, Devil Squirrel, how are you doing? So it'll just be a just chatting and just refactoring stream, I think, for 20 minutes or so. Cargo Run 25-1. Was there even a part 1 and 2 last year? Yes, there has to be, right? Because you have to get 50 stars. Hold on a sec. Where's the button? There it is. Yeah, Mrs. Rainbow had a question, and she trumps everybody. All right. All set up. So, what is Avenue Code? An advent calendar of programming puzzles. Every day from December 1st to 25th, we get 2 parts of a puzzle. Sometimes they're wildly different things you have to do for parts 1 and 2. Sometimes just a little bit more for part 2. Sometimes part 1 is really hard and 2 is easy. Sometimes it's the other way around. You never know. In the years past, year 20 or day 25 usually was just an easy placeholder thing just to congratulate you for making it through. So maybe that'll be one of those. But you never know. Maybe we'll have the hardest problem ever. Like, there's no way to predict it. So you can do this in any programming language you want. There's usually a Christmas theme involved. So we dropped the keys to Santa's sleigh in the ocean this year, and we've gone down through underwater trenches and all the way through caverns and met a lot of creatures, and now we're getting to the bottom of the ocean, where I presume we'll finally find those keys. After reading an explanation at 24 today, I was able to code fully general solution. So Devil Squirrel, Eric actually gave us a link yesterday to a solution which is all done on paper. So you didn't actually have to write any code yesterday, apparently. I don't know if I bookmarked it, but there's basically a way to deduce the answer without writing any code. Yeah, you don't have to, yeah. Let me just say that I saw lots of interesting feedback about this. Some people hated it, some people loved it. One person was like, loved that the problem was fitting so well with the model of a tool that they were really looking forward to using. And I thought it was super tough because it wasn't so much coding, it was figuring out something analytically. And yeah, it's hard for me to do that. I guess I can review what I did yesterday for anyone who didn't see it. Day 24, right? So we were supposed to, the coding part, I would say, if you felt like you had to do it without doing it on paper, which most people had to, write a virtual machine, basically. So they told us that we're going to be receiving some input. That's a sequence of instructions, and it's a virtual machine with 4 different registers, and it has a string of input and a string of, well, is there a string of output? No, I think the output is just the state of those registers, right? And the puzzle was try to figure out the largest input that would give you an output of 0. Or no, not that 0. 0 in variable z. And this is an extra constraint here that just happens to also be 0. You can't have any zeros in your input. So numbers 1 through 9, 14 of them. And just you have to figure out what the program does in such a way that you can pick the input, and sufficiently long that you can't try all numbers that are 14 digits because there's just way too many of them. So you had to kind of figure out enough of the problem to at least narrow it down, and that's what I ended up doing with some help. Couldn't figure this one out on my own. So for example, this is what the program looks like, right? And we studied it a bit. I think what I did is I first wrote code that would like basically implement the virtual machine and see what we get as output. And we were seeing that if we just tried input starting from all 1s up to all 9s, of course we can't try them all, but we tried maybe the first 1,000 of them. We were seeing that every so often we would get the output would be divided by 26. And we would see other like cyclical things, like it would repeat every 10, that kind of thing. So that's as much as I was able to figure out just by treating this as a black box and just feeding input. That 26 had something to do with it. Then I think after struggling a bit to try to figure out what to do next, I decided to study this program and try to figure it out. So I had started making this reverse engineered version of it. So I started tracking like, well, we know if given an input n, and we can figure out things like multiplying any number by 0 gets you 0. So this is just a sneaky way of just assigning 0 to x, that kind of thing. Figured out that indeed there was a lot of math involving taking the modulo 26 in here, or dividing by 26. And where's the divide by 26? Can't remember. It's here somewhere. Oh, right. This a constant. And right, that leads me to the second thing, that realized that you could break apart your program into 14 sections, and the sections were all identical except for 3 of the constants in here were different. So I wrote down what the numbers of all the constants were to make sure. So a lot of them are truly constant, but the ones I marked here, A, B, and C, were different for every one of the 14 digits of input. And then I kind of got stuck again, and then I had to look up some hints on Reddit, and one of the hints suggested that take a look at what that breaks down to, and you'll notice that your output for the next digit is going to be depending on the output of the previous digit, and either adding the input and some constant, or multiplying by 26 and adding that input and constant, doing nothing at all, or dividing by 26. And the steps where we're dividing by 26 are where the A constant was 26. So that led me to, like, the furthest I was able to kind of figure out on my own is that, not figure out on my own, but the most I could solve it using some hints without actually writing some code was that we knew that the to get to 0, we'd have to be dividing by 26 4 times here to get it down to 0. And there's some internal opportunities here. Basically, there are 7 steps during the process where we can get the number closer to 0, and there's 7 steps where we're allowed to get away from 0 by a factor of 26. And the ones where there are this 26 for A are opportunities to basically try all the input digits from 1 to 9 and pick the one where it does divide by 26 and discard all the other paths. So rather than it being a 10 to the 14th power number of possible solutions, it's now down to 10 to the 7th plus 70. And then that put it into the realm of something where I could just have the computers brute force try them all, and then the program's slow, but it actually finds the right answer finally. Hey there, Rally Monkey, how are you doing? To be honest, you managed to solve yesterday's problem by hand using implementation of ALU for visualization of the register toying around numbers. Yeah, that's so the hints that we got yesterday, the spoilers, I didn't read them then, but I read them post-stream, was that you could basically figure out the relationship between like I had here, there was clearly a relationship between the output of one digit and the output of the previous digit and the input of the current digit. But if you take this further, and if you're a little better at math, you could realize that you can min-max this so that you could figure out, like just on paper, what some of the digits were, and the other ones you could derive from those ones that you found already, and basically work it out on pencil and paper, right? So I just had the computer try all possible values of 1 through 9 for all the ones where A is 1, and then for where A is 26, we just look for the one that gives us the lowest output for that stage only. So it just reduced it to 10 to the 7th plus 70 possibilities, which is within the realm of what a computer can do in a reasonable amount of time. So the code looks like this. No, it's not this. It's day 24. Where do I start? Okay, here is where we are parsing the input. So we take the source, cut it up into lines, trim the lines, and then look at the middle of the line. So going back to here, what they look like. The middle of the line is always a register, always X, Y, Z, or W, right? So I just have a simple map. So I mapped them to an index, and then we looked at the first 3 characters to find the input instructions, because those just have a variable, right? There's no second argument. For all the other ones, there's a second argument. So we look at everything from offset 6 on, that's here. And if it's X, Y, Z, or W, it's a register. If it's not, then we parse it as a number. And then we package those things up as the operations arguments, and then we figure out from the first 3 characters again which kind of argument it is, or which kind of operation it is. So we have add, multiply, divide, modulo, and equals. And that's pretty much it. We collect it into a vector, and now we have the program, which they're called Monad, which if I was better at math, I'd probably have gotten a hint from that. But anyway, I wrote this procedure to run the virtual machine, and I used it when I made these unit tests to match these examples that they gave us. They said with this program, it does this. So I wrote some tests to this first one just inverts, or no, it negates the input. So if you give it 5, it gives you -5 out, right? This one, I think it was, if the second number is 3 times the first number, you get a 1. Otherwise, you get a 0. So I wrote a bunch of test cases, et cetera, right? Saw that worked. So I, was going good then. And then we got down to here where it says, just figure out. There are mysterious restrictions, so just figure it out. I'm like, oh, what do I do now? And then, like I said before, just looking at patterns and just doing some experiments, ended up with some help to figure out that there are 4, that we can break it up into to trying to figure out each of the 14 digits separately. And when we're on digits 3, 6, 8, or 9 for me, because that's what my input program came out to, like if I show, oh, I already closed it. Hold on. Show this again. These rows here, 3, what is it? 3, 6, 9, 3, 6, 8, 9. 3, 6, 8. So 3, 6, 8, or greater than 9. 10, 11, 12, 13, right? Those we're going to just look one step ahead and take the lowest output. Every other one we're going to recursively try all possible combinations. So that means this would try 1,000 different combinations, right? Because there's 9 cubed, not 10 cubed. 9 combinations here times 9 times 9. And we just use recursion for that. So that's down here in this else, right? We say for every number in the range, we have a special catch to see if we've already found the solution, we'll end early. Actually, I think I added this post-stream. But yeah, we want to, what was I doing here? Take the input so far and add the end to it, to the end of it, and then call solve recursively. So that leads us down to trying every single combination, and here we keep the smallest output along with what the input was corresponding to it. I called that input candidate. The candidate input and what its matching output value is. So that when we get to the end, hopefully we've found this case where the smallest is 0, which is the answer we're looking for, and then we return that. So if we're in one of these opportunity rows, we know that we don't have to try all combinations recursively. We can just go one step. So instead of having this instead of having it run the program to completion, we just add, similar to this, we just add that n to the end of our current input, and it's not a complete input, but that's okay. We just want to have it, when it exhausts its input, we just want to have it stop anyway. So we run it to exhaustion, and then we take the output, and then find the smallest of all of those, and then given that smallest one, we say if we're at the last digit, then that is our answer. Otherwise, we're going to try to solve the next digit after that. And so this takes a long time from the perspective of a computer. For a human, it takes not that much time. I think it was a minute or less. So it's pretty ugly. I never bothered to clean this up. Oh, this is I didn't show this, how we actually execute instructions. So we have 4 variables. We have our input characters. We just basically say for every instruction, we have an arm, a match arm for every kind of instruction. So an input takes the next input character off and stores it in the variable that we're supposed to store it in. Add will add a variable and either a number or a variable to that. Same for multiply, divide, mod. Equals is a little different. It's if the 2 compare, we store a 1, otherwise we store a 0. And at the end, we just return what the state of all of our variables were. And then I had this special break here for, it didn't start with this, but I had added this later, that if the input is incomplete and we run out of input, then we just break out of the for loop. So we stop executing instructions there. Hey there, Vu, how are you doing? So Vu was working on this day. I never saw if did you get the solution working? Because when I got done with my stream, I rated Epsilon, and I think Epsilon rated you. And I think you were in super focus mode, so I was hoping that you actually solved it. I couldn't stay up long enough to watch. It was, for me, very late. But I hope you solved it. Oh, you got there? Great. Awesome. 5 hours, yeah. For me, that's some of my days this year have been 5 hours. But hopefully you felt really good when you found that solution. I felt sort of good because I had to get a few hints. The days go better if you can figure it out on your own, I think. When you have to like take a hint or two, then it's still nice to solve it, but it's not as good. You went through all sort of emotions. Yeah, like rage and then frustration and then hope and then crushing defeat and then insight and then finally victory, right? Discourage people from hinting. Yeah, so do I. In fact, when I'm working on it, I don't really see chat as much. But one day I rage quit and then I realized later that was not an appropriate reaction. So getting frustrated, I think, I draw the line about how far I'm going to look at a problem before I give up. But when I reach that point where I give up, I'm like, okay, now let's open up for a few hints. Or I might say, well, I'll just work on it the next stream and we'll catch up, right? Being frustrated is a completely human reaction. Yep. But it sucks to watch for most people, I think. Because part of this is entertainment, and it's not really entertaining to watch someone completely like rage quit or get frustrated. I mean, for most people, I think it's a streamer's right to rage quit. True, but I think for me, it wasn't the right thing to do. I think I was happier on those days where I took a few hints, and for me, my favorite part of the focus is implementation. So I don't actually mind if someone gave me conceptually the approach to solve a problem, and I just wrote it in code. I would be perfectly fine. Yep, we're on the finish line. So hopefully day 25, not that big a deal. It's supposed to be your reward for making it through. But yeah, may you do well, everyone who's working on it. So again, any programming language you want to pick, and there are frameworks out there to help you set up your program. I'm not using one. I'm just kind of hand coding everything. What else to say about this? Let's look at the stats really quick. Yeah, so usually a lot of people try the first 3 days, but then there's kind of a drop off in the number of people who keep going with it. And then some of the more tough days, like 19, you see that not as many people completed it. So this tells me a lot of people just skipped to day 20, which is fine. And it's hard to tell whether about these days or if it got harder or if there's just fewer people doing it. One other aspect of it is the people who are really good at it are amazingly quick. Like, this took me 3 or 4 hours with some hints. Some people did it in 15 minutes. Like, on the first day, someone did it in 1 minute and 7 seconds. That's amazing. Amazingly fast. That's less time than I need to actually read the problem. So yeah, take a deep breath. We'll get set up. Usually there's a cool thing that happens with the front page after you get all 50 stars, which is kind of neat. So I've been drinking beer the last couple of streams. Today, it's kombucha. And because of the color, it's, for you, transparent kombucha. For me, it's greenish blue. Okay. Oh, there's one thing that we could do to clean this up, right? We can make this as U size, right? Oh, why am I all in caps? I think you can do that because oh, I size. You can convert a Boolean into an integer, and it just does exactly that, right? 40 seconds. I'm just trying to fill that 40 seconds. 30 seconds. I'll check this in later. How about why do I have different? Did I not check this all in? Oh no, this is a lot of it's day 25 stuff. Okay, anyway. 18 seconds. Are we ready? Let's clear out some of this stuff. 10 seconds. Good luck, everybody. Usually not a toughie. It's sort of a reward for making it there. But let's find out. Let's go. Sea cucumber. This is it. The bottom of the ocean trench. The last place the Slay Keys could be. Unless we missed it on day 12, your submarine's experimental antenna still isn't boosted enough to detect the keys. But they must be here. All you need to do is reach the seafloor to find them. At least you touch down on the seafloor if you could. Unfortunately, it's completely covered by 2 large herds of sea cucumbers. There isn't an open space large enough for your submarine. You suspect that the elves must have done this before, because just then you discover the phone number of a deep-sea marine biologist on a handwritten note taped to the wall of the submarine's cockpit. Sea cucumbers? Yeah, they're probably hunting for food, but don't worry. They're predictable critters. They move in perfectly straight lines, only moving forward when there's space to do so. They're actually quite polite. You explain that you like to predict when you could land your submarine. Oh, that's easy. They'll eventually pile up and leave space for, wait, did you say submarine? And the place with that many sea cucumbers could be the very bottom of the Mariana. You hung up the phone. There are 2 herds. Wait, what? Did I miss something? I missed something there, but that's okay. There are 2 herds of sea cucumbers sharing the same region. One always moves east, the other one always moves south. Each location can contain at most 1 sea cucumber. The remaining locations are empty. Submarine helpfully generates a map of this situation, your puzzle input. For example, so it's not going to be a gimme, but hopefully it's not too tough. If it is, I don't know. I don't know what I have to say about that. Every step, the sea cucumbers in the east-facing herd attempt to move forward one location. Then the sea cucumbers south-facing attempt to move forward one. When a herd moves forward, every sea cucumber in the herd first simultaneously considers where there is a sea cucumber in the adjacent location it's facing. Even another sea cucumber facing the same direction. And then every sea cucumber facing an empty one simultaneously moves. Right, so I get it. So it's kind of like in a line of cars where they're going to kind of stretch out at first. So this one, the east one, will move, and the other one will move out of the way, but not this one. Okay, I get it. So they're laying down the rules of the problem. So, due to strong water currents in the area, sea cucumbers that move off the right edge of the map appear on the left edge, and the ones that move out the bottom appear on the top. I love how they explain it away. They always check whether the destination location is empty before moving, even if that destination is on the opposite side of the map. Well, how polite of them. So that this one will get blocked, right? And then this one will get blocked because this one moves in its way. This one moves to there first and then blocks this one. Got it. Find a safe place. You know what I think this is going to end up? This is going to look like a Christmas tree at the end, right? No, I don't know. Find a safe place to land your submarine. The sea cucumbers need to stop moving. Again, consider this first example. So I guess it's going to say a 4x4. Oh, I see. None of them can move anymore. They're all locked. So yeah, the first thing is to find out when they all stop. Okay, yeah, this is an easier one. We'll just simulate it. It tells us the grid. So we're just going to have a grid. And is it going to be a huge grid for the real input? Of course it is! You have been blue screened by my copy paste. Wow. Okay. So let grid equal input dot lines dot map line dot trim dot cares dot collect into a vector, and then again collect into a vector. Inlay hints, please. To do for the rest of it. Need to make that a function call. My inlay hints should... Oh, there we go. Vector of characters is what I want to see. Okay, then we're just going to loop until nothing moves anymore. And we'll keep a running count. Steps. And we're going to return steps to string. if we get down to here, it's going to be steps plus equal 1. Oh, we need to remember at each point, yeah. I guess I should just make 2 of these grids, right? And then swap between them. So let's make this mutable. Let's figure out the size of our grid. So, ymax is grid dot length. Let xmax equal grid 0 dot length. Okay, then let I think we'll just let's try the brute force approach. Let mute new grid equal vec. Well, why don't we just copy from the other grid? Yeah, and then we'll say let mute moves. And if we get down to the end, if moves equals 0, break. So to consider moves, it's for y and 0 to y max, for x and 0 to x max. They're just thinking a more efficient way of this is the number of the cucumbers doesn't change, so we could just have, instead of a grid, we could organize it as like a memory location for each cucumber, but we also have to have a quick lookup to find like if a space is clear. Anyway, I'll just do it this way for now. We're gonna do this twice, actually. We're gonna say if grid yx equals an east moving one, then if grid y, this should actually be a match. No, there should be an else. New grid yx equal dot to have it move. X plus, whoops, x plus 1 mod x max is empty. Then it moves. New grid. Let's have this let new x equal this thing we calculated. News x. New x. One thing about Rust Analyzer, if you ever accidentally type a forward tick, you get the Rust Analyzer to crash. It loses its mind, literally. That's the plugin I use with VS Code to get the inlay hints and other things for Rust. So if it's free, then we're going to place it there. And we're going to increment the number of moves. Okay, and then basically repeat the same thing on the next line. On the next group, only these are the v's, right? Lowercase v's. Yep. And it's going to be new y. It's y plus 1 modulo y max. And this becomes a new y x. Put that v there. Oh, I also need to clear its original spot. New grid yx equal dot. Okay, let's see. Do I pass the test? Maybe it's too slow. Maybe it's too slow. We should print something. It's too slow. Let's see. Print line blank moves after blank steps. Okay, it's too slow. Too slow could be either I need to redesign this or it just have a bug. I think I have a bug. Right? So let's have it print out what it looks like. Oh, I know what it is. I never moved the new grid to the old grid. Grid equals new grid. That would probably do it, right? Oh, I don't want to run that. What am I doing? Just hit the test button. Wait, why did it quit right away? That should have just looped. Oh, hold on. Oh, we didn't fill the grid. I don't want to do this dot because there could be another one in there. Like the southward facing. This one could be the eastward facing. All right. Okay, that's not right either. That's weird. Okay, where are my bugs? I got some bugs in here. Clone the current grid, and at the end, the grid becomes the new grid we're building. Oh, I don't want to do that, actually. I don't want to do that at all. That's a problem. I don't want to clear it or, yeah. Because we started out by cloning it, so we're only going to want to write changes to it. Okay. This year I've had a lot of bugs. And it's still buggy. What am I doing? If it's an eastward moving, and if the new position's clear, then clear the old position. Oh wait, this won't work. No, this will work because it's putting it in the new grid. We're not looking at the new grid. Oh wait, we also want to modify the grid itself because these ones take that into account. So yeah, I need to do a 2 copies. I need to do that because these ones all use after the eastward ones move when they consider moving. And I have a bug. Oh, the clone. When in doubt, clone. What am I doing? What are any of us doing, really? It makes you think. I know. Puzzles, mostly. Hey there, Eric. How are you doing? Oh, I'm off by 1. Off by 1 is a good sign. That means I probably got it right, but I just didn't count my steps correctly. Oh, yeah. Of course. I gotta count the step before we break. Otherwise, we didn't count the last step. Okay, here we go. Cool. Let's run the real thing. Cargo, run, 25-1. Not even gonna bother to do release build. We got 334. Sorry for the blue screen. 1 star. Continue to part 2. Suddenly, the experimental antenna control console lights up. Slate keys detected! According to the console, the keys are directly under the submarine. You landed right next to them. Or on them. Using a robotic arm in the submarine, you move the sleigh keys into the airlock. Now, you just need to get them to Santa in time to save Christmas. You check your clock. It is Christmas. There's no way you can get them back to the surface in time. Just as you start to lose hope, you notice the button on the sleigh keys remote start. You start the sleigh from the bottom of the ocean. You just needed some way to boost the signal from the keys so that it actually reaches the sleigh. Good thing the submarine has that experimental antenna. You definitely need 50 stars to boost it that far, though. The experimental antenna console lights up on the screen. Energy source detected. Integrating energy source from device. Sleigh keys. Done. Installing device drivers done. Recalibrating experimental antenna done. Boost signal strength due to matching signal phase 1 star. Only 49 stars to go. You have enough stars to remotely start the sleigh. Let's do it. You use all 50 stars to boost the signal and remotely start the sleigh. Now, you just have to find your way back to the surface. Did you know crab submarines come with colored lights? Push button, get 2nd star. Yes, congratulations, you solved every puzzle. Hope you had as much fun solving them as as I had making them for you. I'd love to hear about your adventure. You can get in touch with me via contact info, website, or Twitter. Cool. Or we can just tell him he's in chat. I had a blast doing this year, just like last year. In fact, I might go back and do the previous years in Rust as well. Or maybe pick a different language. I need to learn Go at some point, because that's all in the rage too. Highlighted the Easter eggs in each puzzle just in case you missed any. There was, I think, one Easter egg we found. We found the int code on day 7. We already found that one. No, it wasn't 7. What it was, which one was it? Anybody remember? Oh, look at the colored lights. Ooh, look at that. I didn't notice that before. I guess that was our path that we took. And the crabs followed us all the way down. Was it day 9? No, it was one of these days. Okay. I don't remember which day it had. Was it 7? Oh, yeah. Yeah. I even had a special stream where I went and found it. It was Cargo Run 7-EE, I think. Cargo Run. Ceci n'est pas un encode program. That's what happens if you take the input to day 7 and run it through the encode program from 2019. Because people noticed that these first numbers look suspiciously like encode instructions, which is, you won't know what that is until you did, unless you did 2019's puzzles. But yeah, if you actually take out, dust off your old code for the 2019 encode solutions and run it through, you actually print out that output. There's another Easter egg in the pros. Do it in Go 1.18 beta and only use generics. Is this a challenge? Well, let's see. What Easter eggs did we miss? Carried into deeper water. They're highlighting them, but Oh, wait. I just need to hover. Tank. I need a program pilot for a B-212 helicopter. Oh, right. That's from the Matrix, yes. I need to highlight it. I need to hover over it. Does this premise seem fishy to you? Get carried into deeper water. I'm not quite getting that one. I'm not going to get very many of these, probably. Turns out oceans are heavy. So I'm making some odd creaking noises. I don't get that one either. Sorry if I disappoint people by not getting the Easter eggs. Let the giant squid. That's let the Wookiee win. Yeah. That's because the submarine don't pull things antennas out of their sockets when they lose. Giant squid are known to do that. Don't let the Wookiee win, right? I actually knew that one, but I didn't realize that it was intended to be an Easter egg. Maybe they're breastrum vents. That I'm not going to get. It's probably a math thing. Sorry. Each lanternfish creates a new lanternfish once every 7 days. Someone pointed out that this was similar to another puzzle. I heard you like lanternfish. It was like based on some other year's puzzle. Don't burn fuel at a constant rate. This appears to be due to the modal interaction of magnetoreluctance and capacitive directance. Is that a reference to the Technobabble YouTube video? Everybody know what I mean by that? There's like a video on YouTube you can look up where it's all Technobabble. Yes, Retro Encabulator. Yeah, but there's one that was really old school, so it's probably the original. Unless the original predated YouTube videos of VHS recordings. They must have been damaged during the escape. Yes, just the four-digit 7-segment ones. Whole batch of them must have been faulty. Okay, I don't get that one. 9. Settles like rain. This was originally going to be a puzzle about watersheds, but we're already underwater. Yeah, oh well. So I heard a lot of time goes into making these puzzles. And part of me thinks it might be fun to come up with some of my own puzzles, but I don't know if I would have the dedication to to go through. Is that true? 10 didn't have any Easter eggs? I don't know if I'd have the dedication to spend all year making these. Basically, the Easter eggs are a way for you to talk out a character a little. Yeah, but it's also another challenge, right? For people to figure out what the so I think I only really got 2 or 3 of these Easter eggs when I first read them. So I'm pretty dense when it comes to that. Octopi? I thought it was octopi too. Actually, when I remember reading this thinking that you wrote it wrong. So it's not octopi? Huh. Or is this debating me? I don't know. Octopodes? Submarine Subterraneans. Yeah, this is too many S's. It makes me think of The Life of Brian by Monty Python. Sublime. Oh, you should have put Sublime in there. It would make it even longer. It was the Roman soldier in The Life of Brian who had the lisp. Although it's probably not politically correct of a joke anymore. Finish folding. So I remember when I was doing this, someone in chat noticed that it's another folding problem from some other puzzle, and I think it was one I hadn't done. And wasn't it proven that you can't fold a piece of paper more than 7 or 8 times or something like that? Unless it's a special kind of paper, if we're talking about standard pieces of paper. Instructions. Oh yeah, you know what? This did remind me of another puzzle from, I think, 2019. There was one where you had to calculate chemicals. Whoops. I don't know if I'll be able to find it. It was early on, I think, in 2019. I'm just scanning through to see if I can find it. There's one where you had to find chemical combinations. Was it this one? No, this one was about signals. There's definitely one about chemicals, though. 14? Okay, thank you. Yes, this one. I had a lot of fun with this one. This one reminded me of all the complicated rules to figure out how to optimize things in Factorio, or also in Eve Online to figure out the economy there. Anyway, back to this. I don't remember what day I was on. Yeah, that was the one I was on. Okay, 15. Cannot move diagonally. Let's see what the pop-up is. Can't go diagonal unless we repair the caterpillar unit. Could be the liquid helium or the superconductors. Sorry. 2019-14 is partially inspired by Factorio optimization. Okay, cool. So there's a reason why it made me think Factorio. That's great. Bits. Oh, what did that make me think of? I mean, these are bits that we're dealing with, but there was another thing about it, right? Just be glad it wasn't sent using the Bu-Yankee transmission encoded system, so BYT bytes. Okay, good one. Good one. Yeah, it would have been a lot more complicated. Hi. That's let me guess. This is, when I read this, I thought about every instant messenger application I've ever used at the workplace, where someone's message to you is hi, and they sent it to you yesterday at 4 p.m. and you're like, why couldn't they just say what they wanted? Maybe you need to turn the message 90 degrees counterclockwise. So that would be, it would look, okay, I don't get it. Is that a Japanese character if I turn it that way? I don't get that one. But that made me think of instant messenger chats that start off badly. So you keep a link to nohello.com, Andy? Oh yes, that. So I used to work at Qualcomm. Qualcomm had a specifically a wiki page internally dedicated to training employees not to communicate like that, and it was called it was on a fast link called go/hi. So if someone said hi to you, you would respond with go/hi, and then that would become for them a link. If they clicked on it, they would get this full lesson on what they did wrong. Snailfish math is snailfish math. Oh, it's a double. I like this one. What did I like about this one the best? Oh, I think I already talked about this. I like the fact that we get to explode and split numbers, and that we were doing manipulation within a tree, and that I remembered enough about how trees work and how to traverse them that I didn't get stuck. So that was fun. I love that one. Now we're getting towards the tough ones. Wait a minute, did I skip the... I totally skipped it because I was talking about how much I loved it. Oh, yeah, never mind. My guess is that this is talking about how we're making pairs. My apologies if I'm not getting all the Easter eggs. Again, Raimu's dense. I should probably finish soon so that I can rate someone who's still working on the problem. Let me, in the background while I'm looking at these, get a list of streams on Twitch. Okay, Anthony Wright's code is going. Maybe we'll rate him. Is he still going? I'll just get this out of the way. Okay, it messed up and it's giving me a window without chat for some reason. Oh, Twitch, why you do this to me? There it goes. Okay, while the ad is going, let me finish with looking for the Easter eggs. 19th Easter egg is big. Or 19, I mean. Did I miss it? As in it's not on one line? Or, oh, big. There it is. It was hard to see because it was so small. The deepest parts of an ocean are about as deep as the altitude of the normal commercial aircraft. Yeah. It's kind of crazy to think about the how deep it really is. I think it's when most people look at a globe, they see like the ones that show like the surface of the what am I trying to say? The bottom of the ocean, it looks shallow, but you're looking at the whole globe. You don't get a sense of how deep it really is in places. Yeah. Big. This is going to be a, what's the movie? It's a joke on zoom and enhance, right? That's definitely the problem. It didn't enhance it enough. Must zoom, must enhance. It was the parody on Star Trek. I forget the name of the movie. Someone in chat will probably say it. The challenging to a nice game of chess, right? A strange game. Would you like to play a game? That was that World War III movie. I'm horrible with names. I don't remember them. Just for fun. That many is also in the initialization procedure. Well, you would think it's fun. Why? Okay, that one escapes me. I'm sorry. What? You didn't know amphipods can talk? Well, now you do. I mean, they did flag us down, so why should it surprise us that once they flagged us down that we that we find out that they can talk? I'm probably ruining all these jokes. I shouldn't do this, but I can't resist. It might even damage the ALU. How so? Maybe this is what happened to the last one. Could be. Watch out, you might divide by 0. You landed right on them. Did we land? I thought for sure we would be asked to find the landing area. because that's what it looked like we were going to have to do. I was like, oh, 4x4 area. We're going to scan for that, right? Thanks to deep sea marine biologist who apparently works at BM Middleton Levine Oceanic Research Institute. Okay, sorry, I don't get the reference. But is that because of... I don't know. Sorry, I don't get that one. Anyway, that was fun. Let's switch the baton over to Anthony. That's the actual name of the thing I implemented in part 1? Really? Oh, yeah. Okay. Okay, that's deep. I wouldn't have gotten that. Yeah, War Games. That's the name of the movie, War Games. But the other one where you have to scan and enhance several times. I forget the name of that one. BML name thing, yeah. Right, the name of the Day 15 Part 1 puzzle. Yeah. So, yeah, that's a little bit too deep for me to have gotten, I think. I need to type some characters here. We're going to rate Anthony Wright's code. He's a great streamer. He's rated me a few times. Let's pay him back. The few people watching me. But happy holidays, everybody. Having a code this year is really great. Looking forward to next year. Can't wait. Maybe in the meantime, we'll be doing like 2018, 17, 15, 16, the rest of that. Well, you're welcome, Aneurysm. And thanks, Eric. And thanks for doing Advent and Code. It's brought a lot of people a lot of fun and a lot of challenge. I love a good puzzle. Even if I don't always solve them, it's always fun to try. So let's go see what Anthony's doing. See you there. Bye.